In order to graph this rational function, you have to think of the parent graph, 1 over x. Now I made a little table. I plugged in -1 and 1 because I knew they'd come out to be really nice answers. And when I plugged -1 into this function, I got -1. When I plugged in 1, I got 1. And then I plotted it. And then I knew the graph would look like this. And we'll talk about why. Basically because there's something called an asymptote vertically and horizontally at the x and y axis for this function. Now, what happens is, what's going to happen is the plus 2, the x plus 2, well, if you look down here, make that a coordinate of -2, and that's -1. Kind of like with vertex form of a parabola, HK. So the opposite of this, that right there will be like the original center. See the origin right here? -2, -3 is now the origin, the center of kind of the graph. So it went left 2, down 3. That's the center. And what happens is, at -2, we have an asymptote. So at this center here, this was the origin, now it's down here, we have an asymptote, a vertical asymptote right here. At x equals -2, remember the opposite of this. And at y equals -3, see right here, asymptote, we have a horizontal asymptote. So basically there was an asymptote here, and that's how we got these two green graphs. Now on this new one, I moved the asymptotes over here. And then I recreated the green dotted lines in the blue. Because again, this graph will look exactly like this graph. It's just due to the +3, +2, and -3, you shifted it. You shifted it left 2 and down 3. So it's the same graph as the green, just shifted over 2, down 3, due to kind of, you can think of it as HK. And the red lines again are called asymptotes, and they're created by the opposite of this is your vertical asymptote, and the opposite of this is your horizontal asymptote, as you can see down here.